All right. So Christopher Nguyen, founder and CEO of Aitomatic, and an old friend and one of my go-to people in terms of thinking about things in the AI and machine learning and data space. Welcome back to the Data Exchange podcast. Let's start actually with the title of this episode, which is "What is AI engineering?" So let me put that to you. So, what is AI engineering?
Oh, I have a paper. Let me try to recall the exact words, but we try to put it in a single sentence, and then we can talk about it more expansively. But it is the emerging discipline of building systems, in many cases, life critical systems that have components that are AI, right? AI is sort of the new thing that's going into industry, but we have been building systems forever. In the beginning of electrical engineering, for example, there was the science of electricity. And when we start building transmission system, generation systems, and so on, there are a lot of concerns that transcend just the pure science of electricity. And so there emerged the discipline of electrical engineering. We are at a point in industry, particularly in the field that I work on, where people who care about quality, about repeatability and emerging in AI, right, explainability and so on, ethics, all of those issues are coming to fore with the system that we're building. And so, coming from industry, there's a need for something that we're going to be, for practical purposes, we're going to call it AI engineering.
And the key, based on our previous conversations and my glance at your paper, is that from your perspective, AI is much more than ML.
Oh, absolutely, absolutely. Yeah, I mean, by now, I think most people understand that AI being the term artificial intelligence, you can get artificial intelligence from using many different techniques, right? Even Boolean logic, automated, can be thought of as artificial intelligence. Fuzzy logic, expert systems, rule-based systems, and so on. And then you have machine learning, right? Of course, qualitatively, there is something different about machine learning in that we don't design the algorithms that do the work directly, but we design learning algorithms, and those learning algorithms, when married with data, somehow they discover patterns, and then they create these programs that otherwise humans would create.
So this notion of AI engineering. So, what is the genesis? So, is this based on conversations with practitioners, industry people, academics, combination of all of those, or what exactly led you to start thinking about potentially encouraging people to think about this new discipline?
Yeah, if you look at the history of how disciplines start, they don't come from academia. Academia is sort of the reduction to a pattern, and then we say, hey, let's formalize this, let's systematize it, and let's create a syllabus and academic program around it. But typically, these come from practical needs, right? As I discussed earlier, AI engineering is an emerging or some profession, right? Some formalization of the field is needed to address a lot of the challenges around applying artificial intelligence technologies to the real world, right? And different people sort of are coming at it from different angles. CMU, for example, the software engineering, the SEI, the Software Engineering Institute at CMU has a program, and I think that was motivated really by their relationship or the funding from the Department of Defense, right? So there's one organization that really needs a lot of quality and discipline and security around this technology of AI. In the last 4 years, as you know, I've been part of the global AI effort at Panasonic. And so that includes things like avionics, energy. You may know Panasonic makes all of the Tesla batteries, manufacturing, supply chain, automotive, and so on. These are existing industries, right? These are physical industries. Whereas if you make a mistake on Google,
where engineering is a real specific word, right?
That's right. Life critical systems and so on. And even coming from the this hot new data science, machine learning field, people are now talking about things like ML ops, right? Data engineering and so on. So these are, you can think of all these things as what I call industry intuitions. That say, say there's something that transcends just the basic science of it. We're starting to build systems out of these things, and so let's make sure there's a discipline around it.
So, given that companies, industry, and the people who create courses just recently, within the last 5-6 years, introduced data science, data scientists, and even more recently, machine learning engineers, maybe around the same time as data scientists, data engineers. So they're already kind of in motion with some new roles and some new titles and some new training courses and some degree programs, right? So what makes you think that that people will be receptive to tackling another one, AI engineering?
I don't think it's another one. I think it's the exact same one that we're kind of like blind men and an elephant, right? Data science. You go to a data scientist, they say, yeah, this doesn't feel right. Take specifically something like an IPython notebook, right? It was sort of a hack, right? Created to satisfy some needs.
It's like a Mathematica from the 1980s, right? So,
that's right.
Yeah.
And yet it is now the standard tool for data science, and people are saying, this is really good for some things, but it's not good for reusability. It's not good for refactoring into some kind of software engineered system. I wish I could get some of the software engineering discipline, right? We've known about this for 50 years. Some of that practices into data science. When somebody says something like that, they essentially are intuiting their way toward what we want to call now AI engineering. And the same thing is happening with running ML systems, right? The discipline around monitoring the performance out in the wild, comparing it to what you get while you're doing the internal training, and then a full loop retraining as you have distribution shifts. All of these things are emerging into something where we say, let's refactor this out and let's make sure we teach it in college. Let's make sure we have some kind of certifications around it, right? And if people are going to be designing life critical systems where if you make a mistake, someone dies, let's make sure there's some standards around it.
So I'm looking at, so this is how you folks, as you noted, describe it in a single sentence, right? So AI engineering is the discipline concerned with the qualitative and quantitative design, construction, and operation of systems with artificial intelligence capabilities.
Exactly.
Where the notion of artificial intelligence refers to constructed models, which might include more than machine learning, as you noted, right? So given this, Christopher, it seems like it is you guys have captured something here. So what is the next step? How do you convince the other people to join you on this quest? I mean, so obviously the podcast will promote it, so people will hear about it. So who's part of the coalition now, and how can people get involved?
Right. Well, first, let's go back to when you say you guys, right? We're here talking about AI engineering. So you guys is not just my company, Aitomatic. We can talk about Aitomatic's role in that. But like as I described, people are independently coming at this. So in our working group or consortium today, there are entities that represent academia. There are entities that represent large-scale physical industries, and then there are entities like ours that are sort of supplying the tools into this. If you remember the semiconductor industry, right? There's a name called Cadence, and they supply a lot of tools. And of course, there's Applied Materials, Intel's, and so on. There are industries, and then Berkeley, Stanford, that's academia. So the equivalent of that, specifically today, the Hong Kong University of Science and Technology, on their own volition, seeing their own need, has started a program out of the ECE department, Electrical and Computer Engineering department, to begin to create and craft a program, both at the undergraduate and graduate level around AI engineering. My previous company employer, Panasonic, is sort of a key avatar that represents these large-scale industries that inherently care about quality of in this case of models, right, of the way these things are engineered, have projects and various things that can contribute to this effort so that we can sort of do this in the real way and not just a purely subject-based way. And companies like Aitomatic are contributing tool sets into this this evolution.
So if we look at the inception of data science in kind of the early days, the one group that seemed to really help data science was kind of the online learning community, right? So the Coursera's, the MOOCs, and things like that. So are you going to try to reach out to that cohort? So they're not quite universities yet, but they have a role in terms of getting people excited about a new discipline, right?
Yeah, I guess I think of MOOCs as not a different group, but just another delivery channel. In fact, I don't mean to be dismissive. What I mean is, I think that is going to be the delivery channel of the future.
Right.
Right. So HKUST, the academic material, right? So some of these courses are just existing courses like machine learning classes, linear algebra and so on. But there will be emerging courses that are more about designing systems. So for example, the reason I know so much about HKUST is, as you know, I used to be a professor there.
Right.
Right. And there's sort of a repetition because I started the computer engineering program there about 25 years ago. So that's why there's a department of ECE, right? It used to be EEE, Electrical and Electronic Engineering.
Right.
So I see this sort of the same kind of motions toward this discipline called AI engineering, and so there'll be an AI engineering program there, and I suspect a lot of that material that come from HKUST and those that we will help create can be delivered and will be delivered over these online channels as well.
So I guess my question is, so with AI engineering, unlike data science, right? So data science, in the early days, you just take 1 or 2, 3, 4 courses. You're certified. You get a certification from some online learning platform, right? So do you think that AI engineering is inherently more rigorous and therefore should have a full-fledged degree instead of
I think data science is inherently more rigorous, right? I think what we saw in the last few years in terms of taking something for 6 months and being able to contribute is both good and is also a property of something that is very early stage.
No, right? But I mean, at least from the marketing perspective of the term, those things helped in the beginning.
Yeah.
Then the universities expanded them into more full-fledged courses. But by the way,
right.
I have a pet peeve. The way the universities teach data science is too much on the modeling side, right?
Yeah. But that's exactly what we're trying to address, right? That's why we make sure that there's a consortium of academia which supplies, if you will, sort of the substrate for subject-based education. Like I have a very strong opinion on pedagogy in general, right? I think it should be a combination of both subject-based and project-based, right? And industry, including Aitomatic, right? Because we work with a lot of these large industrial companies, and so industry will supply the project, right, experience. So it's more than just a single subject. You have to combine a whole bunch of other disciplines, but it gives the students that practical exposure, right? So internships are already being provided by these industrial companies.
I guess if I were to guess, so this is complete guess on my part, right? So let's say, for example, HKUST comes up with an AI engineering degree, and then some companies, say Panasonic, start sending people there and they get degrees, and then you have the first cohort of people, and then I think other institutions will follow suit.
Yes.
You don't need a large number, you just need a handful.
Yeah. I mean, the great thing is it's kind of like a startup, right? HKUST is solving its own problem. Panasonic is solving its own problem, right? And to the degree that the 3 or 4 entities that we're talking about, there's a few Fulbright universities also quite interested in doing this. To the degree that it solves the problem that they have, I think that's the best way to get started, right? It's not so much about getting 100 organizations together and say, let's do this grandiose thing. For example, you touched on something quite significant. The thing that a company like Panasonic is really interested in is not just hiring fresh AI engineers into the organization. That is important, but that's not going to happen for another year or two. What's really important to companies is that there's a lot of domain expertise in the existing engineering organization, right? And that's 90% of the value that's needed to build the next future products. But there's 10% that is specific to AI and AI engineering, where companies want to, for lack of a better word, retool, right, or enhance the knowledge and the experience of their existing people. That is of massive value, right? And so they want to address that problem. And so through some kind of relationship that we're helping to facilitate with HKUST, with Fulbright, and so on, they really want to send quite senior engineers to these things. And that's sort of the graduate program. Of course, there's demand from the market for the undergraduates coming in, with the AI engineering degree as well.
So to our listeners out there, so how do they get involved in this AI engineering movement?
Well, we have a website called aiengineering.info. You can go there and sign up for the newsletter. And if you want to be part of the consortium, if any of this sounds like something you want to participate in and contribute to and benefit from, I think that aiengineering.info is the best way to get started.
Very good. All right, so I'm gonna pivot slightly here. We've known each other for many years, and I know that before you spent time in Panasonic, you were basically building tools within Google, within a startup for regular enterprises. By regular enterprises, I mean non-enterprises that are not necessarily in the industrial sector, right? So like banks and healthcare companies and e-commerce sites and things like that. So now that you've spent quite a bit of time immersed in the industrial space, so what are some of the key lessons and learnings, or what were kind of some of the aha moments in the industrial space that caused you to reassess how you think about some of these systems?
Yeah, that's a great question. In fact, it is inherently that aha moment that got me and Aitomatic to this AI engineering thing. I talked earlier about how solving your own problem and then finding your way to this organization or this collection called AI engineering. The problem that we were running into when working with industrial companies, right? Another way to think about it, these are what I call physical industries, which is very different from, say the Google that I came from, or the Facebook or the Twitter that everybody knows about. This is digital in, digital out, right? But 90% of the world, the majority is we're still very much physical beings, right? Tesla cars still have to be built, batteries have to be made, refrigeration systems have to run, you have to go to supermarkets and so on. It turns out machine learning cannot yet be fully applied, right? And the reason for that is, or when I say machine learning, I mean machine learning only systems, even though it is the hottest thing, since sliced bread for the last 5 years. And
which is basically the world you came from, right? So the exactly. pure machine learning, right?
Exactly. That's when we were acquired. You can think of it as a bunch of geeks with algorithms, right? And machine learning algorithms in particular. What we ran into is that there's not enough data for machine learning. Okay, so we try to build systems, and when people come to us, half of the time they have not collected enough data. So initially we just say, you just gotta go back and collect more data. More recently, people like Andrew Ng have been urging people to do that, right? There's little to be done with improving the algorithms more. You got to figure out how to collect more data, collect more labels, get better quality data, and so on. But very soon that answer by itself, that answer is necessary, but it's not sufficient, became insufficient, right? Because there's a lot of lost opportunity. You need to get to market. You need to get market share. Lots of the competitors are at least announcing that they have AI in their products and services. What are you doing, right? And you notice it's AI and not just machine learning. And the aha moment came when and I can talk in greater detail some of the use cases. The aha moment came when we realized there's vast amounts of domain expertise already available in these organizations. Machine learning is a tool, and it is good for some components in the system, but to construct a whole AI-enabled system, you really want to leverage that knowledge that is already present in the organization. And so we began to build, and we've open sourced something called Human First AI, but the essence is about leveraging human knowledge together with machine learning so that you can build a system that you can go to market with in 6 months, as opposed to waiting another 3 years to collect more data. So that's a project that we're on today with Aitomatic.
And by the way, I'll place a link to the project Human First AI in the episode notes. So what you described is basically this set of tools and the realization that you need to be able to blend machine learning with other techniques, including human knowledge, in a principled way.
Exactly. But and very often you start with the knowledge because it's already there.
Right. But this is still in many ways, this is still only one component of the broader AI engineering concept, right?
That's right.
Because this gives you kind of that model or the model or the quote unquote algorithm, but it doesn't give you kind of the entire system, right? So
that's right. So you put the knowledge model together with any kind of machine learning, and you can ensemble them, for example, so that the ensemble doesn't care that it's being fed from a human physics or a fuzzy model together with a machine learning model. The ensemble itself will improve as more decisions or more data comes in, and then you put that whole thing inside a workflow or a graph, because you're really building a system, right? You're deploying a model. And the minute you start building systems, then you realize, okay, we really need something that we've been talking about in terms of AI engineering.
So Christopher, for the listeners who are not in the industrial space, who are, let's say, somewhat more digital space, do you think they benefit from this kind of thinking and approach?
I think, like we say, like we'd like to say, like the future has arrived, but it's
not evenly distributed.
Not evenly distributed, right? So I think what we're talking about, the problems that we run into, apply particularly to physical industries, but more specifically, use cases that have a strong physical component. So recently, I was chatting with some friends at Amazon. I realized that they actually want to do something like this too, for a particular use case that they have. Because before that, I wouldn't think of Amazon as necessarily a target customer, if you will. But I do think the general principle. So when we talk about the customers, this is the light bulb that goes up, right? One thing you can say to people is that you got to get on this machine learning / AI revolution. You're far behind. You better go collect data and so on, and sort of create a sense of panic in the organization, right? But when we talk about the message, and it is true that you actually don't want to start from zero. You don't want to go into a race where everybody, you're like a 50-year-old, 100-year-old company with vast amounts of domain knowledge, and then you want to throw all that away to compete in the ML only world, where you basically have no inherent advantage, right? But maybe you can collect a lot of data. But when we say there's a lot of knowledge that you should, in fact, try to codify, right, and automate, and make sure that these models are merged with, harmoniously with these machine learning models, so that you can start right away, right, with the assets that you have, but then also shift quite continuously, right, into the machine or the data-driven world. I think that message resonates very, very strongly with organizations that know they have a lot of human knowledge assets that nobody's telling them to leverage.
So now as you were talking there, it struck me. So there are domains where maybe it's not maybe the driver is not necessarily lack of data, but just that domain knowledge is available and actually critical. So I'm thinking
Exactly.
of healthcare, for example.
Exactly.
Where
Yep.
domain knowledge is essential for safety reasons or transparency and safety reasons. But it's also, your users are domain experts.
Yeah.
So they probably can help you actually build a better system if you can leverage the knowledge.
Right. Take predictive maintenance, for example. And I think if your listeners hear the story, they can probably map it to something that they're familiar with. In predictive maintenance, in the last 5 years, the machine learning community has come and said, hey, we can help you predict the future, right? And invariably, the solution proposed is going to be an anomaly detection system, right? I'll tell you of course, you know what it is, but for clarity, I'll describe what it is, and then tell you why it is that people settle on anomaly detection, and then talk about why that's not really ultimately the right solution. Anomaly detection, as you know, is an unsupervised algorithm. There are different techniques to get there, but they all revolve around recognizing patterns of the recent past, say the 3 months or the 3 years, and then the next day watching sensors, data streaming in, typically time series data, and then saying, hey, I have not seen this pattern before, right? Something is different. I can't really tell you what it is. I can tell you what sensors and stuff it came from, but I'm not here to diagnose. I'm here just to alert you to the fact that something is different. Okay, and that's why it's insufficient, right? Because past that point, past that alert, some human still has to look at that and determine what to do, right? Or at least diagnose what the problem is. If you tell me what sensors and so on, maybe that gives me some hint. But in complex systems, sensor values alone are not enough to do for machine learning algorithm to do the diagnosis. And the reason machine learning cannot do the next step is because typically that's a classification problem. And so we got to train against vast amounts of label data. Yeah, the last time the compressor failed, the sensors looked like this. And the last time the air filter got clogged, the sensors looked like this, right? So I need a lot of this data, but by definition, machines don't fail that often, right? And then secondly, by the time you stratify it by workload, by exact model number, by climate, and so on, you actually don't have enough label data at all, right? And yet, when you take that, and then you take that alert and you take it to an experienced engineer, right, whose brain is imbued with vast, experience, he or she can then look at the traces and say, oh, it looks like the compressor is about to fail in a week or two, right? So our approach is to take that knowledge and codify it, right? And so here, what I describe is an anomaly, a machine learning algorithm followed by a human knowledge, right, powered algorithm, right? That's already there, and then you can automate the whole thing, and that combination is the real predictive maintenance system that is currently in operation around the world today.
And anywhere you can, but in reality, though, Christopher, anywhere you can codify human knowledge, as long as you have the right tools to incorporate it in a principled way, why not, right? So even if you have data,
Exactly.
Because it'll still make your system better, right? So I go back to the healthcare example. You may have data, but then you have all this domain expertise. What, you're going to leave that on the table?
Yeah, it seems very obvious, right? So I'm kind of preaching to the choir, but surprisingly, when you go to to our community, right, big data, machine learning, there's almost a culture of resistance to that. Well, first of all, the tools are not available readily, so that's quite understandable.
And there's also skepticism to domain knowledge.
Yeah,
I want to learn everything. I want to learn everything from scratch, right?
That's right. There's sort of a purist approach to it, right? And I think that's fine and good. That is the ultimate future 50 years from now, right? But companies need to get to market, in 6 months. And as you yourself just said, right, knowledge is available to automate. So why not? Yep. The tooling, there's an issue, but I have seen, even within my organization, say a few years ago, right, a machine learning person, so whether ML engineer or data scientist, has a really hard time shifting their mind to a system perspective and say, I'm really trying to solve this problem, business problem. I'm not really I don't need to solve it using just IPython and this particular algorithm.
So we've talked about AI engineering and your recent work in industrial AI and the lessons there. So let's close by having you just describe what are some recent trends that you find interesting or give you hope that can help kind of realize some of these things that we talked about, this kind of more holistic thinking about AI in an engineering perspective.
Right. So maybe I'll broaden beyond just what Aitomatic. So Aitomatic is very much focused on knowledge first or knowledge centered AI, right? And that's to get customers to market ASAP, right? And they have the AI systems ready to go together with machine learning evolution over time. But human first AI, the project is, has concerns larger than just getting that system done. For example, there's emerging, from different angles, the question of explainable AI, right? That's just one example of the need, just the human need to understand things, but really regulatory requirements with respect to, for example, if your car killed someone, how do we do forensics against that? So there's this whole initiative or movement. There's something we ourselves have dubbed AI rule, right? The ability to understand and manage and hold the system to high quality standards, right? We're certainly contributing to that from the perspective of.
This sounds like a natural fit to this whole AI engineering umbrella.
Yeah, absolutely. Reliability, right? Yeah. Understandability, right? Privacy, security, and so on. We, as a single company, we can't address all of those things, but that's part of this whole AI engineering movement, right? People are looking at it from these different perspectives.
Yeah, I mean, actually, there's people who have studied safety and reliability of systems.
Yes.
And there's got to be lessons learned from those areas that can map over to these AI systems, right?
Yeah, and there's one thing that I wish the machine learning community would take there's too much politics that are polarizing people, right? And so they're arguing from these political ideologies, and there's people saying that's not the problem of machine learning. The data is unbiased. That's not my problem. Well, it's still going to be somebody's problem, right? Yeah. And so hopefully putting it in terms of AI engineering, help make it less polarizing, right? But I think these are real issues, right, with real concerns. And so as we build these systems, we have to be aware of them and address them.
Right. Cool. Thank you, Christopher.
All right.